You're listening to Data Center Therapy. Please take a number, and an engineer will be right with you. All right, everybody, welcome back to Data Center Therapy. I am Matt Yeti.
And I'm Chris Crow.
Thanks for joining us. We have a little bit of a unique recording situation here. We once a month we all get together, all of us engineers, and we have what's called Engineering Day. It's a really good opportunity to roundtable topics, debate about what we're seeing out there in the field, kind of get all of us together in one room once a month and try to sort out what we're all dealing with. So today, if you're hearing the non-pristine studio, and if you listen to episode 5, you're not used to that anyway. But we've got a little background noise here. We are currently in Kirkland at a meeting place, and we've got the entire crew here. So there will be some background noise, but rather than sweat it, we're kind of embracing it.
It'll be a fun time. Almost live, except that it's a podcast. And I get a beer, so I feel like it's, this could be better off no matter what.
The listeners don't know when we're recording this, so it could be 5 o'clock in the evening as far as anybody knows.
Let's go with 5 o'clock in the evening.
We'll go with that.
It's past 5 o'clock in the United Kingdom, so
and you are still within your jet lag window, so theoretically,
that's what I'm going with.
There you go. I'll jump on board with that. Well, thanks for joining us. This is episode 6. What we're going to go for today, as far as the topic goes, is NSX. Does that stand for anything, by the way?
I don't think so. That's so. I've been asked this a few times with things like ESX and GSX as well, which, and I don't think NSX actually stands for something. ESX, of course, for those that don't know, I guess this is a bit of a bar bet trivia if you go to bars with really boring people, stands for Elastic Sky X. Apparently, Elastic Sky is what you pay a marketing department a lot of money for, and the X is what makes it sound cool, and that was whoever the marketing guys.
They've since moved on to Xfinity, I think, right after they named that one. They just switched the formula.
I've missed a career in marketing.
But of course, if you're not familiar, NSX is a VMware product. It was an acquisition a number of years ago.
Yeah, from Nicira, and it's really supposed to be the VMware's foray into software-defined networking. And software-defined networking it can be kind of a nebulous term, but in essence, software-defined networking, instead of defining our networks by hardware devices and switches and routers, the intelligence for all of that is going to be run on open systems. So instead of a specialized routing device, you can have a router that, in its simplest form, could exist inside of, say, a hypervisor. Imagine a Linux box that has routing enabled that can be doing some firewalling. Of course, we'll find it's a little more sophisticated than that. And so NSX, from an overview, I've given a number of done a number of implementations, given a number of talks on this, and have been trying to really drill down into the essence of what NSX is. And what NSX is providing is really 3 different things that I think are kind of unique. The first is a centralized way, and probably the easiest to understand, a centralized way of managing these virtual routers. So I can deploy a virtual machine from something that's entirely integrated inside of the vSphere Flex interface at this point. It's starting to come into HTML5. And I can configure firewall rules, NAT rules, I can configure load balancers, but everything we need to understand about how these work is it's just a virtual machine. So if I take this and I hook it to 2 different network segments and I make it the default gateway, it does that. The second thing that NSX provides, and this is a bit unique, is a VXLAN overlay to be able to have additional segments that are running across a transport layer. Now, VXLAN is an open technology. It's similar to VLANs, except instead of 4,096, we have somewhere in the neighborhood of 16 million different VXLANs. But make no mistake, they aren't individual segments. So if I have a VXLAN number of 5,000, and it's just a segment, without a router, it doesn't do anything interesting. We'll talk a little more about that later. And the last thing that is unique about NSX is a firewall that interacts at the VNIC level, but is globally managed. So it's actually a shim that goes in on the ESX box, and I can create a firewall rule that says, I want these two virtual machines that are on the same network segment, the same collision domain, whatever term you want to use for that, and I can tell them, you can't talk except on port 443, and I can enforce that. Now, because I'm integrated with VMware, a lot of the power of this software-defined firewall, and we'll refer to this sometimes as microsegmentation, the ability to firewall everything from everything. I can. One of the powerful things about having this integrated with VMware is I can use VMware objects to manage this. So, for instance, I can say I want this folder in VMware to talk to this other folder,
or this tag,
MacBook, or this tag,
right,
or this security tag, or I can even do DNS lookups. I can say any machine that has a web in its name. I can even integrate this with Active Directory in the case of like a view or a terminal server, and I can say things like, if Matt is logged into this box, he can't get to anything. But if Chris is logged into this box, he can get to all of the management consoles.
Story of my
life. Like to lock people out.
I'm glad you brought up the microsegmentation, because from a systems-focused approach to the work that we do at Ivoxy, from my standpoint at least, the idea of being able to firewall off, for lack of a better term, an individual VM in a virtual environment is really compelling. I mean, from a physical standpoint, throw out virtual networking and tell me how you're going to accomplish that with the traditional way of networking, with physical hardware. And you're talking about a separate network for every single machine going through a firewall with countless number of virtual interfaces to firewall through. It's basically, I mean, the word is it's impossible, ultimately, unless you want to layer over a software firewall and deploy and manage that outside of the network.
Even if you say put a firewall on top of if you put a firewall on top of the virtual machine and use the Windows firewall or something like that. Now, of course, it's important to remember that we are operating at that VNIC level. So imagine, again, this is software defined. So there are plugins. Other companies, Palo Alto or Trend Micro, can actually put shims in there. So you can have examples of behavior like, if I detect a virus on this virtual machine, I can shut down the firewall. And it doesn't even matter if the machine is compromised, because the firewall is being enforced at the VNIC level that is just outside of the virtual machine itself. Now, make no mistake with microsegmentation. It can be difficult to put together. Imagine all of the firewall rules that would have to go in to get a zero trust model in a modern data center, when we couldn't assume things like two machines on the same segment can actually talk to each other. There are tools to assist for that, by the way. I would certainly encourage people to check out VRNI, the Network Insight product that can do things. And I think kind of an unsung hero in VMware's product line is actually Log Insight. Imagine if I send firewall deny requests over to a log system that understands NSX, and by the way, you could of course do this with a syslog if you're looking for the right things, and then you can visualize. So I'll often print out a report to say, all right, I have a catch-all rule. I want to look at all of the source, destination IP addresses, ports, destination ports, of course, and then a record count over a particular time that I'll use to feed back into the firewall. But the times that I've done this, they are certainly projects. So implementing NSX microsegmentation is not a freebie. It's not like virtualization where when you consolidate a bunch of servers, you're saving money, and there's an ROI on this. The ROI for NSX is security.
Right. That
nothing trusts anything else, which I think has quite a bit of value.
But like you said, requires a heavy amount of planning ahead of time before you go just start ramming in product. That VRNI, the vRealize Network
Network Insight.
Network Insight is I've seen that in action, and you get beautiful visualizations of your traffic flows inside and outside the network. And I don't know, it's not free from what I understand, but VMware will be happy to run a demo with you, I believe, for a period of 30 days.
Yep, and we can even assist people with that demo. We have abilities to grab keys and stuff. And actually, with some of the licensing changes that have happened to NSX, that's actually included in some of the licensing tiers of NSX now, which is nice. So that's sort of NSX in a nutshell. I spent a little time diving into the firewall. It's important to note that the firewall component will work with any port group. However, it requires a distributed virtual switch to be supported, but it does not require any of the fancy VXLAN stuff to actually work. Now, a more difficult thing, I think, for us to wrap our heads around is the VXLAN portion. And this is one I don't see adopted as often because it does require a bit of a network refresh. But implementing VXLAN looks something like this. I have my ESX servers, and I add another VM kernel interface. That VM kernel interface needs to talk to all of the other ESX servers that I want to be able to talk to that need to participate. And that can be between sites, between vCenter servers, between clusters, any real distribution you want. The one requirement is we have to have an MTU size of 1600. That's required for the VXLAN header, which is actually only 50 bytes and another 50 bytes that's reserved in order to work. It can support routing, provided your firewalls do. And once you have that sub-layer done, I can create VXLANs. I can then assign virtual machines to VXLANs. And just like you would expect, if I have two virtual machines that are on the same VXLAN segment, they can talk, provided there's not a firewall in between them. And it actually can talk efficiently. VMware is also using a shim to do some of the things that we would expect to make this efficient between sites. It's doing broadcast suppression. It's doing, suppressing unknown unicast and suppressing multicast, where it actually has a method that we really need a visual to go into, but it has a method of distributing those packets without having to actually send a broadcast packet to the entire set of segments.
I had a customer who had a DR site, and they were looking at NSX, and one real benefit was, hey, my ISP can give me a stretched layer 2 network. It's going to cost big bucks. Or they can hand off routed networks at each side. Now I can leverage VXLAN to still essentially have a de facto layer 2 network across the sides with all the benefits of a multi-site protective topology that NSX provides without paying the ISP, getting gouged.
Money.
Yeah.
You can also even extend this into your physical network if you do the right things under the right circumstances. So, okay, we have the first bit of this, which is VXLAN, which is now a layer 2 segment. Doesn't help us a whole lot. Well, I have routers that I can plug into VXLAN segments that can then do routing. But remember what I said at the beginning, those routers are glorified virtual machines, except for one other concept that goes with VXLAN, and that's the distributed logical router. And this is difficult to understand. I'll shortcut a lot of this for our network folks listening. It's a lot like Anycast inside of ACI systems. But what it does is a piece of this router exists on every ESX server. And so, if a virtual machine pings its gateway, it actually pings just the ESX server. If the virtual machine needs to route to another virtual machine on the same ESX server, the ESX server handles that routing. And cleverly enough, if the virtual machine needs to talk to a virtual machine on the same or different segment that's on a different ESX host, the packet will go directly to that ESX host without having to do anything weird. This means that I can get 10 gigabits of throughput per ESX server that is inside of this, and we'll call it, for lack of better terms, a federated environment. And that was the clever bit that's being implemented here. Is I have this distributed logical router. I have multiple edge routers, usually in an equal cost multipathing configuration as soon as it gets sizable enough. And now, the way I often diagram this is my entire network topology sits behind the ESX host. And the only thing my network guys had to worry about was one transport VLAN that's between my ESX servers that, remember, can route, and a way to hand off routing information, usually OSPF or sometimes BGP, or sometimes in certain environments even static.
So you mentioned 10 gig.
Yes.
Allow me to play the skeptic here, right? And, thinking virtualization, we're talking 10 gig or 40 gig with a lot of our connectivity that we see out there in the field at our customers now. Am I really, take a traditional network mind, and you kind of look with a nervous, skeptical eye at bringing that stuff virtual. What happens if that ESXi host happens to be busy at that moment? Am I dropping packets? Are we queuing up? Do we have a buffer issue like we would potentially in a undersized switch? Yeah. I mean, what does that look like now that you're virtualizing all of your network traffic?
Yeah.
I'm going to go.
10 gig enough,
my
and
old school
how does it fail?
Yeah.
So obviously, the switches that the ESX servers plug into need to be line rate high buffer switches. But what happens fundamentally if the ESX server runs out of bandwidth? Well, you need a method of doing traffic shaping. That can either be done manually, or what we would certainly suggest is using network I/O control, so we can effectively traffic shape. Now, keep in mind, network I/O control only works on the egress from the virtual port perspective of a distributed virtual switch. but it does provide a share-based way of managing network throughput. So let me give you an example. If I have one virtual machine that needs 10 gigs, it gets 10 gigs. However, if a second virtual machine comes online that needs 10 gigs, then it's going to share. And if the ESX hypervisor needs a certain amount of bandwidth, it's going to get that. So ultimately, how does the shared distribution work? Well, it depends on how you have it configured, but essentially we're going to carve up our bandwidth with a worst case allocation, so if everything turns on at the same time, between management functions, virtual machines, their network traffic, storage, vMotion, and some other ones that are in there, network-based provisioning operations and such. And what you get as a result is, in a worst-case scenario where everything turns on at the same time, we don't overrun buffers. So I've never actually had a situation where we've done that. Now, that being said, most environments that we run into are over-provisioned. I have 80 virtual machines, all with 10 gig adapters running on ESX host. But the reality of it, and what I'd even encourage people to do with a tool like VRNI, how much bandwidth are we really using? And it tends to be, I'm actually surprised, even in sizable environments, if we're sustaining more than 10 or 20 gigabits a second.
Yeah, people are thinking about all these desktops as well.
Yeah.
With gig links, and I'm connected. I'm tied into a closet that has a 1 gig uplink back to my core switch.
Yeah.
And they look at that with concern, and it ends up not typically being a big issue.
And these are great conversations to actually have with your network administrators, because that's what they do, is figuring out how to oversubscribe things. And you should have conversations with your network administrators and engineers a lot more anyway, because we think of even with bandwidth allocation, how we can overcommit things multiple ways, right? I have a blade system that's overcommitting networks to the ESX servers, and then the ESX servers are overcommitting networks to all of the virtual machines that are running on them. We want to have intelligent conversations about that, and not just say, well, I'm sure we have enough bandwidth. And we certainly also want to employ strategies to ensure that we don't drop packets. And sometimes that's even going to be doing things like, let's say, for example, we're going to tag our packets with different priorities so that our network administrators don't have the same problem.
Sure. Well, I see a couple of large benefits here. I think NSX, you can struggle to sell it in terms of, what do I want to focus on? Do I want to focus on the security aspect, which is very real, and if you're running a network out there, you're dealing with this issue whether you want to or not. And on top of that, then you the other side of that, in my opinion, is the virtualization of your networking functions, like you talked about, VXLAN, distributed routing, distributed firewall rule sets. And you can kind of sell it for either or, and not necessarily both.
Yeah.
But what I found is, like I said, from a server standpoint, the security is paramount. But what really is attractive to me as well, say goodbye to forklift core router replacement cycles. I mean, I'm looking at a couple of our network engineers right now, and how many nights have we spent? And it's always a night, right? It's always a maintenance window where you're cutting over your core router to a new platform, an updated platform. And thankfully, this is not a 3-year cycle kind of thing. Usually you get at least 5, probably 7, and maybe 10 years out of your core router, depending on your workload. Well, if you can go ahead and say, I'm not going to have to worry about forklifting that switch in long nights and potentially longer weekends, and I can just say, well, hey, really the only physical thing backing this network are my line rate top-of-rack switches that link it all together, and those are redundant and split. Then if I need to replace those when they go end of life, I swap one at a time, and all this. And configuration on those is all VLANs.
Almost nothing. Yeah,
almost nothing, right.
Yeah, it's rare that we see that. And I'd say one benefit that I find in building on all of this with a software-defined network is, imagine that I have a kind of tying into our last conversation with automation. I mentioned one of the things that's necessary to get a server built is sometimes additional networks, sometimes firewalls being configured, things like this. It's easy for me now to just do an API call to build a router, to build a new segment, to have a set of firewall rules that is
have that by default siloed off, so you don't have to drag your firewall guy in and he's stacked up until tomorrow.
I don't even have to know the IP address of the thing that I'm protecting beforehand, because I'm just using the virtual machine name.
Right.
And so this is really applicable for cloud provisioning and infrastructure as a service. It's also really applicable for test labs. Imagine I need to suddenly spin up 100 different networks. In fact, we do this for our Voxy training classes. When I get a roster of students, I run it through a script, and it uses NSX on the back end to build all of these layer 2 segments. So every student gets their own network segment that all uses the same IP addresses, that has exact copies of all of the machines, instead of anything like shared labs or something like that.
Yeah, yeah. Well, you hit the nail on the head. I mean, we've kind of been dancing around it, but as we're running into in pretty much all technologies now, automation really can make something like this sing.
Yeah.
Where a lot of times, and this is not the case here, but a lot of times if you're looking at technologies, you're seeing at this point in our industry advancements and refinements of certain technologies, slightly different ways of doing things.
Yeah.
But the leap now, we're not seeing the leap of physical to virtual anymore in a lot of ways, right? That wow, vMotion is really a thing that works.
Yeah.
That kind of, I don't know about you, but nothing's blowing my mind like that.
I don't have to demo vMotion
like
anymore.
like that used to, right? It doesn't impress anybody. I think the next leap now is the ability to automate these things.
Yeah.
Where and to your point on our last episode, when we talked about you can enforce standards as much as anything with automation. The automation can automate things, right? But it also enforces standards, which with things sprawling and more people wearing many hats is almost as much of a challenge as actually doing it.
Yeah. Which I certainly a point that I probably should have underlined more is it's great when you have those standards to automate against them. If you don't have those standards and start automation, you can make bad process much, much worse. So
how many times have you walked into a customer and we're talking about backups, right? And the first question is, well, what is your current backup policy? And everybody kind of looks at each other.
Yep.
And that's not the fault.
Shifty glance sideways.
Everything forever.
Yeah.
And,
yeah.
You know.
And a lot of that is because we don't have standards and we don't know, as IT people, that this stuff should be, a lot of times is things that are really business decisions that we pretend to do in IT at times.
Yeah.
At least I find so.
Yeah. So have you come across anything in the last week, Chris? And now that we've talked about NSX for a bit, of course, if you have any questions or want to go into an even deeper dive, and Mr. Crow certainly wouldn't mind that, you can always hit us at podcast@ivoxy.com. And hit us up there. We can also comment, I believe, on our blog, on our website, ivoxy.com. Have you seen anything in the last week, since as we kind of slide into our "I've never seen that before" segment here, that really blows your mind?
No, not more than any of the background noise of issues. I actually had a bit of a catastrophic failure in my lab a couple of weeks ago that was. And what's going to be unsatisfying about me saying I haven't seen that before is I haven't seen that before, and I don't know why it happened.
Ooh.
But management on the ESX hosts completely failed after
all of them.
Just so one to start with.
Okay.
I rebooted that host; it was fine. Management died again, and I had to actually force the server off. None of this services.sh restart.
Right. What were you trying to do that the management agents were failing were getting in the way?
It dropped my lab actually has monitoring, so I'm out and of course on a date with my wife, and getting a text from my lab saying,
I'm sure she was just swooning at that point.
Oh, not so much. Said if you touch this, then I'm leaving. There's the bartender looks cute. So I waited to check on it because, after all, it is a lab, a home lab, and my family's one request is if the lab fails, it has to fail open. So it wasn't affecting anybody but my OCD tendencies. Rebooted it, happened again, and then the second host, completely different manufacturer. Right, we're talking a Dell versus an HP.
And this is
had the same problem.
Coming disconnected from the cluster.
Disconnected from the cluster. Management agents are dead. I can't use the web interface of the 6.5 system, but the VMs are still running.
What did you change?
Nothing changed.
Nothing.
I even keep a change log for my lab.
Oh, of course you do.
And nothing changed.
This guy. Everybody in the room is rolling their eyes right now, just so you know.
I have that reputation. Now our listeners know that I'm not cool anymore.
You still had them fooled, too.
So, and of course my solution was to simply wait, and when I got back from my most recent trip, and I'm sure we've all had this with home labs, I didn't gently try to fix it or just reinstall the ESX hosts.
Yeah.
No, I leveled everything but the domain controller with 6.7 and started from scratch.
You were at 6.2?
6.5.
6.5, I meant.
Yeah. Update, 6.5 update 2.
Yep.
I'd have to look up notes for the patch level. So, yeah, haven't seen that one. Certainly a reinstall I think would have fixed it, but I'm obviously overdue in my home lab for 6.5 for a while, or 6.7, excuse me.
You know,
for a
I don't
while
want to go
anyway.
too far off into the weeds, but part of my lab is 3 little nooks, those little Intel boxes.
Yes. I avoided that.
Yeah, you know, in hindsight, I probably would have went in a different direction. I now have a super micro little mini D
nice.
box that's really
Nice.
nice. You can stuff it full of RAM, full of storage.
Yeah.
It's got a fairly beefy, I think, 8 or 10 core CPU
wow.
in it. It's nice. But I was attempting to run vSAN on those 3 nooks, and it's for all accounts supposedly supported, right? It's a supportable configuration.
Yeah.
I mean, I dread the idea. I'm at home, right? So we have power issues.
Yeah.
Even gracefully bringing that thing down, it does not want to come back. And then one VM at a time will all of a sudden, and admittedly, credit where credit's due, I think the USB thumb drive install of ESX is a little shaky on one particular host. But basically, I'm running everything on one host with 128 gigs of RAM, which fits everything. And then what I do is I try to cheat, and I just use Veeam to replicate to the Nook side of things, just in case in an emergency, and it will be all right. But next up is to leverage that Azure tunnel and start running some of my home up there, and then let Ivoxy handle the bill.
That's a perfect way to do cloud when somebody else is paying for it. More of us need that agreement with somebody.
Very good point. I just ran into something. I had never seen it before, but it's not that unusual. But we were doing an Exchange 2010 to 2016 upgrade on-prem. Fairly small environment, maybe 150 users, nothing large. Single server kind of thing. And as Exchange ages, the idea of roles in Exchange kind of goes by the wayside. Every Exchange server is going to just collapse, and there really is no CAS in mailbox role anymore. It's just mailbox that handles the CAS stuff as well. The only role specific that you can still deploy is the Edge role. So if you want to control, or you want to have a smart host to relay out or control your internal and external mail flow, you can deploy an Edge role. Other than that, every Exchange server is a mailbox server, or potentially, right? I had a customer where we got to the point where I say, okay, here we've tested our migration. Things are all good. Everything's mail flow and clients are pointed at the new side of things. They're able to properly proxy back to 2010. Everything's good. Go ahead and start migrating. This is how you do it. These are the commands you use. Go. At your leisure, right? And they got about halfway through, and I got a call in the evening and said, one of these users is migrated. It says it's migrated, but Exchange comes up, or Outlook comes up as disconnected, and I can't auto discover. I've deleted the profile. I cannot add them. It's just, it goes and searches. I put the proper password in, and then it just kind of fails silently. Really weird. They end up finding a blog post because I'm troubleshooting. I'm like, okay, what's the user? Or maybe they renamed the account. Is their email different from their user object? Is auto discover somehow disabled for this user? It was the auto discover pool, the app pool in IIS on the Exchange server, just needed to be recycled.
Wow.
I mean, it's just so weird, right? But apparently it's a bug. Exchange, as great as it's gotten, in my opinion, my favorite Microsoft product. It's a little black boxy still. I'm from the Linux side of things where I can go do send mail or queue mail or postfix, and I can really dig into SMTP logs and see what's happening. Microsoft's log viewer leaves a little to be desired. I shouldn't have to go ahead and start flipping switches on and then make sure I don't turn them off. Make sure I turn them off before I fill up my volume.
Interesting.
The SMTP on Windows is not as easily inspectable, right? Anyway, that
is a different one.
It was a really odd thing. From what I understand, it's a bug. Exchange 2016 is up to CU 8, cumulative update 8 already.
Oh, wow.
The dev team's very good, and they rev very quickly. But, just a weird one. I'd never seen it before. I've seen a lot of stuff with Exchange. We do Exchange migrations. We do 365 migrations, although I would say the lion's share are still on-prem.
Interesting.
I would argue, not to get too much off on a tangent here, I would argue if you've got a working on-premise Exchange environment that's not taking too much time to, really the only maintenance you have on-prem versus cloud is patching, really, because you still have to manage distribution lists, mailboxes. You're going to have a better experience on-prem. You just are.
I could see that. A lot of my customers that are sizable certainly still keep it on-prem. Of course, at Ivoxy, we host it. I'm not sure I would change that just because I can have non-technical staff do it. So I think it's a lot of what people
If
are
our
after.
email goes down and it's on-premise, who's fixing it?
Oh, you are.
And what happens if I'm a customer?
Well, then everybody's going without email.
Right. So I think a company like ours, it's a perfect cloud service thing.
Yeah.
Now, we have days where, I would say a couple times a year at least, where you'll get an email from one of our inside people who said, has anybody gotten any email today? And they haven't. And then you log into the 365 dashboard and, oh, there's a yellow light. Yeah, they're done.
Oh, interesting.
And picture yourself a customer, or our customer, or user, and I'm the email administrator at company X, and the cloud goes down. You come to me, hey Matt, when's my email going to be back up? Are you going to love it when I put my palms up and I say, I don't know, Chris?
Yeah, but I love that sort of thing, I have to say. And see, all this time when I wasn't receiving email, I figured that people just didn't like me anymore. That's good to know.
But I mean, pragmatically,
It's not unpopular.
Yes,
It's the
if it's
cloud.
not my problem and I can't fix it, that's fine. But that's not an answer that people want to hear.
That is true.
I would rather,
for any organization.
as a former ops guy, I mean, I'm
Yeah.
born from ops. I'm still ops.
Yeah.
As an ops guy, I want to have control over anything.
Yeah.
And at the very least, if something goes wrong, I want to throw it very near to choke.
Yeah.
And I just fear that with cloud, you are so at the mercy of things that are way out of your control that you just have to be careful. You have to take that into consideration, and I think your user base needs to be prepped for that.
Yeah.
That's
because imagine
as
if
well.
it was something besides email that really did matter, like EMR systems or
stuff that
or
federates,
PACS
stuff that
or-
federates with the cloud as well.
Yeah, I'm
You've
thinking
got
a lot of
Skype,
medical things.
Skype for business too.
Yeah.
You've got people want to pick up a phone and hear a dial tone.
Yeah.
That above all is.
Yeah.
I have one little anecdote more. Wow. Right out of college, I interned for a local vocational school in upstate New York, and out of college they hired me full time. And one of our first projects was to switch from an old analog phone system. It might have been digital, right? But to VoIP actually. This was
Okay.
a Nortel phone system.
Okay.
So with the actual underpinning system, we replaced the handsets as well.
Okay.
And I'm not going to identify any names, but the person in charge of the project, who was really driving it and being an evangelist inside the company, never really talked to who are the people who really need them are the executive assistants.
Oh,
The
interesting.
people who have the extension banks, the add-ons on the phone that have your 20 extensions and have to really use the phones, never really interrogated them about how do you use this. So he came and said, look at this new Nortel phone.
That sounds like
it's
a
got
project,
6 buttons, and guess what? They're soft buttons. You can program them this and that. and so we put it in. The phone system worked. But it was, I don't care how many soft buttons I have. Where are my 20 shortcut extensions? I am now taking 3 times as long to do my job.
Yeah. User acceptance and scoping. That's something I remember Ryan mentioned with his end user compute talk that can be so important. Makes me glad I work on servers.
Best laid plans, right?
Yep.
No good deed goes unpunished. And any other cliches anybody else that has maybe that want to fill in. Well, I think that's probably good.
Yeah,
a good point
I think
to wrap.
so.
Thank you for the relatively deep dive for a
No, you
podcast
bet.
for NSX. If you've got any other additional question about NSX, we're going to be putting together workshops where we talk about this, and then again, NSX and automation hand in hand.
Yeah.
I would say, right?
It helps out a lot because it's, within a mostly static network where we don't have the same security considerations, it's not the same value proposition as larger, more dynamic ones. And a big part of what NSX does is certainly providing some of that security.
Sure. Well, thanks, Chris. It's always good to chat with you. And now, face to face, not over Skype. So this
I know,
is good.
This is a different experience.
Good
so
use
I think
of the time.
Now we should go probably play some mini golf and have another beer. And for those that want to check out the Flat Stick Pub in Kirkland, it's been a fantastic venue.
Absolutely. Chris, thanks for joining. Thanks, everybody, for listening. This is Data Center Therapy. If you've got any questions, hit us at podcast@ivoxy.com.